Hey guys, it's time for the 17th episode of F4. Today will be all on the Beyond the Basics of Programming. We have three awesome guests today, and I'm not going to actually be talking too much today because, well, I'm not a programmer. So I'm just going to be moderating today. It's going to be a little different, but it should be a great show. So before we get into actual topics, we'll have everybody introduce themselves. So Adam, introduce yourself.
Hello, this is my second time on an F4 web show. I'm the co-captain, driver, and lead programmer of Team 225 TechFire.
All right, and then Alec.
Hello, everybody. I'm Alec from Team 226. This will be my first time on the F4 web show, and I am the lead programmer for this coming year.
And lastly, Jesse.
Hello, I'm from Perth, WA, as part of Code and FRC, and I also run OpenRio.
All right, so we're going to kick it right off with going beyond the level of good enough to move. So the first thing that everyone else is going to talk about is version control, whatever that means. Go. So whoever wants to start.
Okay. Yeah. I guess we should just go around and say who uses what.
Right.
Sure.
We use Git. Yeah.
Also
What do you
Git.
guys-
We also use Git as well. It's a nice, clean way to
Solid.
both keep your changes tracked like a history so you can roll back, as well as having multiple programmers work on the same project, because what's commonly known as sneakernet, carrying around a single USB drive, getting people to copy and paste things onto it, is far from an elegant solution and wastes a lot of time. And it's also very easily screwed up.
Yeah. Plus, the infrastructure that's in place for Git at this point is just unparalleled when it comes to the relatively free and open solutions. There's some commercial solutions out there, but they're not really worth it for FRC teams, in my opinion. So, yeah.
All right. So
Do you guys? Well, quickly, do you guys use private repositories and stuff?
We do. We use private repositories for what we call research projects, which are projects that we're not sure how they're going to turn out yet.
Okay.
They're kind of very much in development. We use private repos for that, and we use public repos on GitHub to just kind of release everything out, because if we write some code and someone else is having trouble, instead of saying, well, here's what we did, we can point them to it and they can see it working in context as well.
It's handy for the end of year release. I think somebody from what team was it? Exploding Bacon? I don't know. Somebody always puts together a list on GitHub, but yeah, it's good for that too.
Now the
and
BPL lib itself is there as well.
Yeah. Also, quick shout out, if anybody doesn't know, the GitHub Student Developer Pack. Definitely check that out. I'm pretty sure it's still a thing. I got that like a year ago.
Comes in the GitHub parts too. There's
Yeah, but
stuff.
GitHub offers a ton of free stuff for students, so
steal my
everyone should
domains
check
off
that out.
them. Get all the free domains. All right, so the next thing is vision. So who here actually did vision processing?
Yay!
All right, so
Raising my hand, but you can't see.
all right, so everyone. So I guess talk about what you did. There's a lot of different implementations of vision processing, just talk a little bit about it. Great. All right. So whoever wants to start. Yeah.
Sure.
Yeah,
I'll talk about it a little bit if you want.
Yeah. Go for it.
Yeah. So the way our team did vision this year is actually me and one of our programming mentors. We got together and we brainstormed ways that would be efficient to do vision, because we realized that.
All right. I'm glad that we can all hear.
guys
I'm
have
sorry.
audio?
Did my mic?
Yeah. It's cut out.
Oh yeah, it's cutting out.
Yeah.
Oh.
Sorry. Anyways, as I was saying, me and our programming mentor, we got together and we brainstormed ways to kind of adequately handle vision processing on our robot, because we realized the onboard processor of the Rio is just not capable of doing those, like running robot code and doing vision all at once.
Yeah, don't do
and
that.
so we
shoot yourself in the foot if you do that.
Yeah, really. And then so we came to the decision that we were going to use a Raspberry Pi for our vision, actually, and so that's what we ended up doing. And so our Vision, we wrote our own, I want to say, not structure, but we wrote our own implementation, I guess, of OpenCV in Python, actually. And then that's what the Raspberry Pi on a robot runs. We call it SharkCV. And so we basically have that running during matches.
All right. So what do you guys do, Adam? All right. Adam's frozen. Jassy, what did you guys do?
Okay.
Oh.
Well, we also did a custom implementation of Vision. So in our case, we used a Kinect camera, which was it got a very keen eye from some judges and other students. But we used the Kinect camera for a few reasons, and I guess what I'll talk about for a second is what to use in terms of cameras, language, framework, etc. when you're doing vision tracking. First of all, in terms of camera, a very common choice is the IP camera or USB webcam, usually included within the kit parts, I believe. So every team has access to it. Those are nice and they work as long as you have a green LED ring. Although they can be a little bit of a pain to work with some specific libraries. Personally, we use the Kinect because of its infrared. So when you're tracking a goal, we can turn on the infrared mode of the Kinect, which basically makes the whole goal light up a bright light. Everything else black. It's hard to explain without a picture, but essentially what it means is that it's really easy to get a track. It's really stable too, because most events are indoors. So there's not any IR light coming from your sun.
Most.
You don't have to worry about it. Yeah, most.
Yeah.
What was that one event which was open roof?
Was there actually one? I think so.
Yeah.
I think it was one in California, where they
California,
like.
yeah.
Okay.
I don't remember. What the original-
Yeah, I was joking.
I know that-
didn't actually know.
No, I was actually pretty sure there was one in California, but I don't know if it was this year. They California changes like locations for stuff a lot. But I know that we went to Google to talk about like our robot, and they of course are interested in software. The people that we were with, so they started talking about like random ways to like do vision tracking. So they were talking about like LiDAR and like stuff like that. But they were also saying like Kinect would work, except your original's at the Javits Center, which is completely glass windows. So like the entire thing is just glass windows. So there's plenty of natural light, which is great to save the environment and bills, but it's not too great for vision with IR.
Right.
Okay, wait. When you get some time, go into Google and search up Curtin University Engineering Pavilion. It's this giant glass building where we did all of our vision tracking tests. Whenever we did it, we had to face a robot away from the window towards the center of the room.
Nice. Yeah.
Anyway,
So.
in terms... Go ahead.
Yeah. Well, I mean, I was just gonna quickly run over how we did ours. I don't know if I missed anything insignificant because Skype crashed and then started updating. So A+ Microsoft. But yeah. So we did ours throughout the season with an IP camera. Like the typical white axis one that you see a lot of FRC teams using. And then we actually sent it through the FMS. At comps obviously in the shop was different, but through the FMS to the driver station, processed it on the driver station with a Java app, and then sent data again through the FMS back to the RoboRio. But actually, I guess it was through Smart Dashboard that we sent the data. I mean, that worked well enough for us. We actually have a new solution. Well, an additional solution, I should say, that we're going to be running with for IRI that employs some fancy Android stuff, which I'm excited about. So that's the gist of how we did ours. It worked pretty well for us. I mean, what kind of times did you guys see on your vision lineups?
That's an interesting part. I'm going to quickly explain what our framework was. Ours was offloaded as well, so I'm glad to hear that none of us did it on the RoboRio. Although we were using a different kind of coprocessor, much like you, Alec, we initially used a Raspberry Pi, but then we swapped it out for something called the Pine 64, who I got in contact with before the season started, and they sent us some development boards. And we found that we were able to do vision tracking in C++ OpenCV at 30 frames per second with a theoretical of 45, which was very useful. all this was done on the robot, of course, so we weren't sending full frames over to the driver station, partly because of a reason that
Yeah.
has a long latency with it. And
Yeah, that messed with us, and that's part of the reason why we're updating the system. I think even just the processing, we could only push like really I think 10 to 15 frames per second, so it wasn't great. But with the new one, we're getting like I think it was like a 60 millisecond latency, so I'm happy about
that's not
that.
too
Nice.
Yeah. Oh yeah, and the image processing is happening at like 35, 40 frames per second. So
All right. So that's vision. The next thing is custom dashboards. So I'm not really well versed on even what that is at all. So Adam, if you want to start even explaining what that is to someone who might not know.
yeah, so there is the standard solution, I guess built-in solution, the smart dashboard, and dashboards are basically just a way to display data for debugging or even like competition purposes. Like if you want to know, I don't know, if you want your robot to show you if it's lined up, let's say for vision, or how far it's gone or something, you can easily print things, or even like what we did a year ago. You can select your autonomouses through it or something like that. So yeah, like I was saying, smart dashboard's the standard one, and then there's a couple of ways to do it with your own build. Last year we actually did something that we internally called like, oh gosh, I forget what it was, like Fire Rio or something. We were planning on building it out and making it more dynamic and releasing it to the public, but that never happened. But I'll try and pull up a picture here. It was like a material design web-based one. I'm curious to hear if any, like what custom solutions you guys have done.
So, okay, in terms of custom dashboards, we've done a custom dashboard for the last 2 years, and we've done it in a different way for each of those last 2 years. First off, I guess I'll explain to the people watching why you would want to build your own dashboard instead of using Smart Dashboard.
Yeah, it's probably a good one.
I think the biggest reason that people do it is because Smart Dashboard it's kind of hard to read. And when I say that, I mean, yeah, sure, you've got a label and then a value right next to it. But when you're in the middle of a match and you look down on the laptop, you don't want to see like 0.9 font. You want to see big button, which is either red for stop or green for go, right?
Yeah, I yelled at
Or-
our programmer
Honestly,
about
it's
that.
ugly too.
Or some kind of diagram, right? Which is why people tend to write their own dashboards, or even write a plugin for Smart Dashboard, because you can do that now. The second biggest advantage, which I find is the biggest motivator for most people, is you get bragging rights. You can say, hey, we wrote our own dashboard. Isn't that cool? Judges, look
and
at
then
us.
you get the Engineering Inspiration Award for it, right?
Yeah.
Shh. That's all part
Wait,
of the
did you
plan.
actually?
Not for the dashboard. I'll
I was gonna
explain
say
more
that
about
would be
later.
that'd be a little easy.
And
This is cheeky.
apparently, Eric, one of our brand new members, is actually the lead developer of FRC Dashboard. I've never used it. I don't even know what it is, but apparently
Oh, I've
it's a
seen
thing.
that.
Yep.
It's a web-based thing, I believe.
Yes.
So there's different kind of dashboards which you can create. So if you do choose to make your own, just as a warning, dashboards, if you don't really know what you're doing, they do have a high likelihood of going wrong. And
Yes.
it's always a game of, will FMS forward my ports today? So you need some kind of, backup plan.
Nice.
For us in 2016, we used a web UI, which is in general faster to prototype, a bit more flexible, and much more familiar to people. But it is more processor intensive on the driver station. But if you're not doing a read for
Now, how did you run the web UI? Like on the Rio?
So we ran a server on the Rio, and what that did was it served up static pages, and using WebSockets, we were sending data back on something called a heartbeat. So instead of sending it back once every periodic tick, which is, I believe, 50 times a second, every 20 milliseconds, called a heartbeat, which is a very, very simple way to crash your driver station laptop. We were sending them back at about 1/10 1/10 of a second, so only 10 hertz, except for vision information, which was being sent back at 30 hertz, so it could be refreshed and redrawn. So we did that with a web UI, and we found that was a really nice way to do it. It looked nice. Once you look down, you could say, okay, here's a diagram. It's showing me the entire field of view of the camera, where the targets are, and it's telling me whether it's okay to shoot or not, just in case our auto align doesn't work or something like that.
Right.
But in 2015, we used go ahead.
Yeah, like with the with Vision, it's kind of a tie-in. Like this year, we didn't necessarily have a custom dashboard, but we had a window of our Vision program running because we were doing it on the driver station. So we had like crosshairs and stuff in case we needed to manually line it up, like you said. Yeah.
We did something similar. We were actually using HTML5 canvas, and we were just drawing on rectangles with the X, Y, width and height locations, and then just doing a simple angle calculation and putting it in degrees, just rendered as text above it. I don't have a picture because taking a screenshot in the middle of a match is not a good idea. But I'll see what.
That's why you do them in practice.
And
yeah, I have a couple from practice.
Just so everybody knows, you cannot take out your phone mid-match and take a picture. You will get a yellow card.
Did you try that?
No comments. It wasn't me personally. Okay, the next thing is motion planning on autonomous. So I'm guessing this is like closed loop versus open loop control for like autonomous kind of stuff. So yeah.
So this kind of ties in with Vision a bit. Just before we get too far into it, I want to talk about Vision and alignment. So during the teleoperated period, we made a choice to not do auto alignment. Reason for this is because auto alignment tends to oscillate a bit, and any small change can cause that oscillation to be a bit out of whack. Usually the tolerances are just not correct for it to get in. And we found that it's much easier for a driver to just look at the driver station, do one quick turn, and already be within a couple of degrees of the goal. This comes down to your driver's skill. You can do it assisted if you want, but we found that it was more time efficient in our case, it was just me as the driver. It was quicker for me to just turn the joystick a little than to hit a button and wait for it to align. And
yeah, I mean, we played around with that.
It's important.
Yeah, we kind of turned into a funny little internal arms race on our team during drive practice after the build season ended with the practice robot. We kind of were racing manual alignment with the crosshairs, flashlight alignment, and vision alignment. And so I think initially it was more time efficient to actually use the flashlight or the crosshairs, but I was so stubborn on speeding up the vision because I wanted to use software. So it ended up kind of pushing our software to a next level where we were getting alignments and like I think at the peak before we had to change some stuff because of some mechanical weirdness. I think we were hitting like half a second to 3/4 of a second alignment, and then like for the whole like process of shooting, it was like a second or a second and a half. So when we got to that speed, we decided let's go with the auto align. But I mean, definitely if you don't have the time or the resources to put into setting that up, I'm sure manual alignment can work really well too.
Yeah. We got vision alignment to get down to be really quick, and within about a degree or two as well. It's just, once you get it on the field, for some reason all the constants need to be changed. So that's all right, because the carpet at our university is slightly different to the carpet on the field. But anyway, motion planning and autonomous. Let's just start out by saying.
There, actually. One correction to make: it's a foul, not a yellow card for taking your phone out. Nick actually experienced that one as well, so he was able to correct me on that. The next thing is there's a question for Adam from Nick, which is what changes did you make to your software to make it faster?
Oh well, I don't want to say let it be a little sloppier, but we dialed in on exactly how precise it needed to be, and I think that ended up being like 0.8 of a degree. because earlier we were a little more constrained with it. So we opened it up a little bit to the optimal spot where we thought, enough shots per time where the trade-off was ideal. And then it was also just a couple hours of aggressive PID tuning to really just nail it on the head. Another thing, especially if what's slowing down your vision is oscillation, 90% of the time it's not actually your PID loop, and it's something with your communications or how you're processing the images. The way we did it with the driver station side processing, we actually initially didn't realize that we were processing images at a slower rate than the Rio was reading the error from the camera. Which, looking back, it's kind of a really dumb mistake to make. But so we had to lock it down to make sure that it was only reading the error once per image process, which is kind of a convoluted system to get that to work out. But eventually we got that. So once you have the Rio and the camera in sync, then that lets you really get your control loops to a good spot to get the optimal time there. I'm trying to think what else we did. Yeah, I mean, it was really just finding the ideal, strictness for the loop, and making sure all the communications and loops were at their, best constants and tuning.
All right. And then motion planning and autonomous. I think we're up to that.
Okay. So I think most of us can agree that a robust autonomous is a good autonomous, an autonomous which will run each time, even if, say, okay, something's failed, the robot's not going to sit dead on the field for the entire match. But a smart autonomous is an even better autonomous. The difference between the two is that a smart autonomous is versatile. So if we take it in the kind of case study of the Stronghold, that can mean an autonomous which can go over multiple defenses, even if that means writing more than one autonomous routine per se. It's also got a little bit of self-correcting to it. So this is where stuff like vision and in some cases even gyroscope feedback can be very, very valuable. Because, as perfect as we like to think we are, field reset crews sometimes put the robot at a little bit of an angle or a little bit too far away. So having an autonomous which can correct for that is great. Now I know this sounds a bit rich because for the most part, our autonomous was just going straight forward. But that's because we were diagnosing other errors, but I'm not going to get too far into that story.
Yeah, actually, I mean, I can speak a little bit to how our system worked this year. I know there were some Delphi comments wondering about that. So, I mean, like you said, with the versatile, we actually had a modular system that I set up where there was an interface for autonomous, or there was like a main, there was like a master class for each position that you could have, whether it was in the midline as a spy bot or do nothing. And then there were interfaces for autonomous defense and autonomous courtyard action, like what you wanted to do in the courtyard. And then there was also another, like a Boolean for coming back. I believe initially I named it two ball, but it got changed to come back because mechanical constraints kind of weren't feeling the two ball. But basically, so, and then on the driver station before the match, the driver would just select, or I would select where we were starting from, what defense we had, basically high goal shot and then come back, and it would just kind of string those together into an autonomous program and execute it. I'm sure that'll be released then when we do our annual code release, so people can check that out. It's really not that hard. You just kind of have to be comfortable doing abstract things in object-oriented situations. And then also, we did the auto align, of course, in autonomous, because there's really no other way to line up a high goal unless you're like insanely good at motion control. But I don't think that's a thing. So that's really the gist of our system. The other thing I'd like to say about auto is be overly prepared when it comes to the things you write. I know we probably had this year it's kind of hard to say because it was, it was like making combinations of things. But I mean, from year to year, we have dozens of autons that we never run, but are tested and ready to go in case we ever need it. Like, I mean, we literally did have a Spybot auton. We never spent much time testing it, but I actually had it programmed. And so, I mean, we never once did that in the season. Or like, last year, especially for Recycle Rush, with the different combinations of things you could do in teleop with, picking up things with partners. I had so many different autons written, like, grab the center can and go backwards. And like, we tested it a couple times. It was simple stuff. So, it only takes a couple seconds to test. But, just having that ready, especially if a team that's going to be asked to, cooperate with like another team, like last year, if there was a team that had like a 3-tote that needed the center one, center can removed. And if you're, the team on the caliber that, you'd be helping them out, maybe removing that, make sure you have that ready, even if you weren't planning on it from the get-go, because that can really help your performance at a competition.
Yeah, if the programmer of my team is listening right now, take notes on that, because we had a single autonomous mode this year to drive forward, all right? But the thing was, we didn't have a second selection for like whether like we weren't gonna run an auton like that match, because there would be once in a while like there was just no place to start, and we were the kind of team that will just like give it to the other teams, like whatever, I don't care.
We got to the point in autonomous this year where we actually kind of scrapped all our routines before, because we found, all these nicely motion profiled trajectories that we want to follow, that's going to get in the way of this other bot. There's 2 other robots on our alliance trying to do the exact same thing as us. So what we ended up changing it to was a duration-based, straightforward control, because get the crossing. If possible, you could do a high goal shot as well, but often we would get too close, and we didn't want to back up too much to kind of negate that crossing.
Right.
What we ended up doing was we ended up using our web UI, to host our configuration files. So the framework which we build our robot off, it has support for JSON configuration files. So what we did was that we had those loaded in the web UI in kind of like a little text box. And what we would do is that I remember before a match, someone asked, okay, we need you to go more forward than before so we can get around behind you. How long is it going to take you to rewrite your autonomous program? And I looked at my laptop, typed like two buttons and went, done. So
yeah, that's always great.
If you can have it changed on the fly, that's the best. Like, even you can do it through Smart Dashboard, I believe, as well. Just change a couple of variables.
Our programmer writes his autonomous as an XML, so that's a thing.
Oh. Yeah. Yeah, there was a situation this season. I'm not going to name any names to not embarrass anybody, but we were working with a team, and we needed them to do something simple in Auton. It was like a tiny change to what they already did. Like, can you hold your arm a little higher or something, right? And we were like, are you able to do that? I'm like, yeah. They said they were in Java, so I'm like, even if you don't know how to do it, I'll help you. And they're like, yeah, let's take you to our programming mentor. So I go up to the guy, and he's like, yeah, we can't really make that change because the entire thing is pre-generated as like a motion profile, and everything is in that together. So it would take us like a half hour to open that up and change it and figure it out. Like, no. So don't overcomplicate things if you don't have to, because they weren't even using like the motion profiles really, because like their system broke down and stuff. So keep it sweet and simple and easy to change. Honestly,
if you're
Speaking
autonomous, you're just gonna drive
not
forward.
overcomplicating.
Just drive forward.
You need a motion profile for that. Sorry to tell you.
Do you really? Because we never missed an autonomous this year, Jassy, and we were using drive forward for 3 seconds at 100%, and it worked perfectly fine.
Yeah.
Also, it's 3 seconds, not 30, and slam into the other driver's station wall, because that's not necessary.
Yeah,
I have been known to get very salty.
We never did knock someone else. We there was like, I think rough terrain, it would hit into the alliance wall, but it wasn't enough power. I think actually when I changed us to brake mode, it didn't like hit at all. Mm-hmm. So.
Oh, that's good.
Yeah.
We had motion profiling working this year, and I'll talk a little bit more about that soon. we had it working to about. It was actually pretty accurate. It would follow the path within about a 2 centimeter deviation, which is pretty good considering we're using tank treads. So, yay, I guess.
Now, what was it? Was it a 2D or a 1D?
2D. So you can plot
Oh, okay.
a course on the ground in.
Right.
We use meters because we're from Australia, not feet. And you basically say, okay, I start at 0, 0, go to 1, 1, or 1, 2, and then the next point go to this, and it'll generate a nice smooth curve in between them. That was done through an early research project, and I'm going to throw around that buzzword a lot, of the Pathfinder project, which is now open to everyone, which is pretty heavily based off of a talk I believe the Poofs did with 971. At, I think it was 2015 Worlds. It might have been 2014, but I think it was 2015.
Yeah, no, it was 2015. I was wait.
I think it was
Was
2014 actually.
Yeah, it was 2014 because I sat in on it, and if it was 2015, I definitely would not have been doing that.
Yeah, I actually put in effort into
yeah.
watching that. So. I
Yeah,
didn't understand
anyone
that.
who's interested in doing any motion control for their team, definitely watch that. It's more than worth the hour that it takes to watch it. I mean, it's an amazing seminar.
And they have examples to go along with it, which is great.
Also, this year's Vision seminar, that one blew my mind. I'm like, wow. the stuff that the Poofs were doing this year for Vision was crazy. Like, storing. I mean, you can only really do it if you have that kind of robot with the turret, so that you can be tracking the goal at the same time as you're moving in any direction. So for a bunch of teams, it's not even physically possible. But like, if you design your robot to fit with those kinds of things, like they showed what you can really do. So, yeah.
But as a general rule of thumb, motion profiling is only really useful in niche cases. So in 2014 it was great because the field was nice and open wide, you didn't have any big defenses in your way. Although some teams actually don't really use them for driving. I know 971 uses it for their I believe in 2015 they used it for their actual arm which pushed the totes out, and I believe they also used it this year as well. They had a lot of motion profiled subsystems to make sure that it's accurate down at the second.
Yeah, I mean they had a full full state controllers from that.
We actually used it this year to do a angle turn based on the gyroscope. So instead of doing a PID control, which tended to oscillate a lot, especially with gyroscopes which like to drift, we used a motion profiling thing instead. And so that basically meant that it didn't have a lot of overshoot, if any, and it was also very quick and snappy. In fact, it was like, I think I clocked it at like a third of a second or something.
Right. Yeah, I mean, while 2D motion profiles are only really in certain cases, the 1D is like almost always useful. Whether it's a trapezoidal motion profile, driving straight, or turning. So,
Let's see. Do we have anything else in the doc for this?
I think it's probably a good idea. Adam actually did a video. I don't know when, but I found it on the internet, and
it was 2 years ago. Yeah.
Yeah, and it's on PID theory, and I don't know what else, but it explains PID pretty well, which I think is.
So for the motion control beginners.
Yep.
Yeah.
So I'm just gonna put.
The reason we don't talk about PID as much is because there is a plethora of resources that explain it way better than I could ever do off the top of my head.
PID theory and robotics.
In terms of actual motion control, there's another one which people tend to overlook, which is during the actual teleoperated period. Sometimes robot drive isn't the best option. So for those of you who maybe are listening to this and don't have as much practical experience or just didn't know that this existed, robot drive is essentially a class where you give it a joystick and you give it some motors, and it will do all the math in between to make the joystick go to the motors. Now, this is great if you want to get driving really quickly, but sometimes it isn't the best option. So for us, we have a custom joystick implementation with some custom control stuff as well. But before I get into it, I just want to stress experiment. Find out what's works best for your driver. Have multiple profiles even, so that they can switch between them during testing, find out what works best for them. Every driver is different.
Nick is wondering
Yeah, I
when
have
it
something
would
to add
not
to
be
that,
the best
after-
option.
Not be the best option? Oh, for robot drive?
Yeah, when would that not be the best option?
So, for example, this year was a very good kind of example of that, and it's actually the reason we shied away from robot drive. This year we used 2 joysticks, and we had one which controlled the shooter and one which controlled the drive base. But using the triggers, you could choose which one controlled what, and if you held down both of them would go kind of like the 2 joysticks on an Xbox controller, but way bigger for each side of the drivetrain. But what we did this year is that while it was in single-handed mode, so one hand for driving, we locked the turn speed to about a quarter of what was being input into the X value of the joystick. The reason for this is so that it's much easier to line up accurate shots manually, because the smaller output you give, but the larger distance you cover, the more accurate you tend to be, the less you tend to overshoot. Because drivers, unless they've been doing it for a long time, they have this very horrible habit where they'll go, okay, how fast can I go from resting position to all the way left?
Yeah.
Which tends to jerk around the bot quite a bit, and it might look right, but then the bot will rest to a stop and it will kind of be wrong. But what we did is that if you wanted to quick turn, say to turn around really quickly in GTO, what you would do is that you would twist the joystick, and that would add another modifier to it. I forgot what we actually called it. It's some weird name. But this is just a very basic kind of demonstration of how you can put math into your periodic robot code to make the driver's experience a little bit better. But honestly, the off season is the best time to take your last year's robot, this year's control system, and just play around and see what works. Put math in there, just go crazy. Who knows, you might find something which no one's ever done before, and then you'll get mad Chief Delphi rep for it.
Alright, so we're just going to play that video. It's about 10 minutes long. Yeah, so I'm just going to mute you guys and play the video.
Junior Challenge submission. Robots. They are currently among the most new and exciting of industrial control systems. They are revolutionizing the entire world, from automating industry with cutting-edge production lines and collaborative robots, to inspiring the next generation of engineers, scientists, and mathematicians. Typically, to be of any use, robots and other industrial control systems have some kind of output that affects their system and the world around them. Now, how does the output device know what to output? Well, sometimes a robot may simply be receiving commands from a human operator. That's me, by the way. In this case, the human picks a target for their robot, then gets feedback from their senses, such as their sight, and adjusts the output of the robot accordingly to achieve the target. However, autonomous robots, or robots that operate without human control, are much cooler. Remember that human operator we just talked about? Robots and other industrial control systems operate in much the same way. They have a target, or set point. They take feedback from sensors to know how far away the system is from its target, and then adjust the output of the system to achieve the target. Before we get to the math behind this output, a very important concept to see here is error, which can be defined as the set point minus the value of the system. So basically the distance from the system's target to the actual value of the system. Now, based off of this error, the robot needs to calculate an output to correct this error. A widely used and very good way to do this is the PID theory of control, and this is what I'm going to explain to you in this video. Let's break down PID. The acronym stands for Proportional Integral Derivative. Each one of these terms describes a way that PID reacts to the amount of error in the system. If you haven't learned calculus, then the second two terms might not seem so intuitive. However, the proportional part should make sense. It means that part of the output is directly proportional to the current error. Before we really dive into what these parts of PID mean, we need to take a look at the equation that drives this theory. It can look a little scary at first, but don't worry, it will all make sense in a second. As you can see, there are three terms here: the proportional term, the integral term, and the derivative term. Each term has a k, which is a constant gain. Note the subscripts. K is usually different for each term. K sub p, K sub I, and K sub d essentially determine how much influence the p, I, and d terms, respectively, each have on the output. Now, let's break this equation up into parts. First, let's take a look at the proportional term. It is quite simple. It is just the current error multiplied by the gain. This means that the output of the function is directly proportional to the error in the system. In other words, if the error goes up, the output goes up. If the error goes down, the output goes down. Clearly, the proportional term will get the system closer to the target. But if you think about that previous sentence some more, you might begin to see the problem with using just the proportional term. To better understand this, let's take a look at the graph of a P controller, that is, a control system using just the proportional part of PID theory. Here, the dotted red line is the set point, and the blue line is the value of the system. As you can see, in the beginning there is a large error, and so proportionally there is a large output. This large output causes the system to quickly jump up towards the set point and then overshoot it. Then this negative error causes it to rapidly decrease. The system then oscillates, and due to the fact that the p term produces an output proportional to the error, the system will settle at some value below the set point. At first this might seem counterintuitive. After all, the whole point of the control system is to reach the set point. But think about it. Remember how we said that because this function produces an output proportional to the error, if the error goes up, the output goes up, and if the error goes down, the output goes down? So then think about the situation around, say, this point. The output tries to make the system get closer to the set point, but then the error becomes smaller, and so the output becomes smaller, and ultimately the system just goes back to where it was. The system eventually settles down in this way. The error present once the system is more or less settled is called the steady state error. So how do we get rid of this steady state error? We add the integral term. For those of you unfamiliar with calculus, an integral gives the area under the curve of a function. This might be a little difficult to wrap your head around if you are just now being introduced to it, but what you need to know is that in PID theory, the integral term is essentially a buildup of the error in the system. Let's compare the graph of a PI controller, a control system using both the proportional and the integral parts of PID theory, with the earlier graph of a P controller. Looking at this new graph, we see the same initial ramp-up that we saw earlier. However, the integral term causes the system to shoot up towards the set point more rapidly because it is accumulating the error from the past, and once again we see a big overshoot. The proportional and integral terms then work together to bring the system back down below the set point, and the system oscillates once again, but this time it's around the set point, and this is due to the integral component. Think about it. Because the integral term is an accumulation of the past error, on the initial jump up to the set point, the integral term is accumulating the positive error and giving a greater and greater contribution to the output. Then, when the system overshoots, the accumulation of this negative error cancels out some of the earlier accumulated positive error, decreasing the contribution of the integral term to the output. This happens over and over again until the system eventually settles on the set point. Notice how now there is no steady state error. Do you see why steady state error is impossible to have with an integral term? It's because over time, the error would accumulate and the integral would force the output up until the accumulated positive error would cancel out with the negative error. It's this repeated need to cancel out the accumulated error that makes the system oscillate around and eventually settle at the set point. Now our graph looks much better. The system actually reaches the set point, and it does so in a fairly timely and accurate manner. But if you see the overshoot that happens and think, that's a problem, in many cases you'd be right. To combat this, we can add in the final component of PID theory, the derivative. Again, this is a calculus concept, but it's a little easier to grasp than integrals. The derivative is essentially the rate of change of a function. So, in the context of PID, the derivative is basically the rate at which the error is changing. So let's think about it. If the error is decreasing at a faster and faster rate, that is, the system is getting closer and closer to the set point, then the derivative term will become more and more negative, decreasing the output. To see this in action, let's add a graph of a PID controller, a control system using all three parts of PID theory, to our earlier comparison. As you can see, adding the derivative has really reeled in this system. Looking at the graph, we can see how the output decreases as we get closer to the set point. Thanks to this, there is much less overshoot. The system slows down as it approaches the set point, which can be very important in the practical application of PID theory in mechanical systems. There is essentially no oscillation, again a good thing in practical systems, and the overall time it takes the system to finally settle on the set point, or the settling time, has been greatly reduced. This is about it when it comes to PID theory, so let's quickly recap with this final graph. The proportional term of the equation is what makes the system initially start sharply moving towards the set point, and is mainly responsible for the overall fact that the output of the system responds proportionally to the error. The integral term makes the system approach the set point even more quickly and ensures that there is no steady state error. Finally, the derivative makes the system slow down as it approaches the set point, making the system achieve the set point in a more controlled fashion, with less overshoot, oscillation, and settling time. So by now you might be thinking, well, this is all well and good, but what do these graphs even represent? Let's turn to First Robotics Competition Team 225 TechFire's 2015 robot, Phoenix, for a demonstration of PID at work in real life. Let's watch Phoenix try and maintain a single position amid disturbances which are provided by a person pushing on him. Did you see Phoenix move in a way similar to the graphs that we've been looking at? Let's take a look at the actual position versus time data recorded on the robot and break down this movement. Although in this case the system is starting already at the set point, the general shape of the graph should look quite familiar. We can see the robot resting at its starting position in the beginning. Then it is pushed away from the set point by the person. The PID controller then takes over to return the robot to more or less its original position. There is some steady state error here because of physical constraints such as the robot's inertia. Then we see the second push from the person, and the PID controller bringing the robot beautifully back to the set point. PID control can also be used to make Phoenix move autonomously. Here's an example of when the set point is a position in front of the robot. And here's an example where the set point is an angle, and the output of the system is rotation. Of course, there are much more sophisticated ways to make robots move, which give the designer very specific control over the velocity and the acceleration of the robot at any particular point in time during the movement. These methods are actually employed on Phoenix, and even here PID plays a very large role in them, but this is an expansive topic for another day. Hopefully by now you have an understanding of what PID theory is, what it's used for, and how it works. Also, I hope you have enjoyed my real-world examples of the application of PID theory.
Okay, I think you guys can hear me, so basically the video ended. I'm just getting you guys back up. Alright, you guys are back. So,
Awesome. Hello.
hope you enjoyed the video. The video will be linked down. Yeah. So, great.
Nice video, Adam.
Yeah. Thanks. Yeah, the reason it kind of gets a little fast-paced at the end is it was for a competition to explain like a science or math concept, and the limit was 10 minutes, and I ended at 9 minutes and 59 seconds, so it gets a little crammed at the end. But,
Nice job there.
Yeah, definitely.
Thanks.
Alright,
Top notch.
so, the next thing is utility and framework. So I think Jassie's done some weird stuff with framework according to one of the questions rather, so I think you should start on this one.
Okay, so for those of you who don't know, I started up something called OpenRio, which is kind of like a robotics framework, open source kind of organization thing, and it's taken some contributions from a lot of teams around the world, and it's basically trying to stop code rewrite so much and just trying to get the community to work together a little bit, because there's this massive stigma around programming where it's like, I know the code's the exact same, but if it's not written by my bare hands, it's not as good. So essentially, what I mean by utility and framework is why rewrite your code base each year? So if you take a look at a lot of teams, you'll see their code from year to year is almost the same. They'll have a lot of classes which are the exact same. They do the exact same utility functions. Their robot base is almost identical. In most cases, their drive system will be as well, although that has been known to change. The point is, why rewrite this each year? It wastes a lot of times, and when you're only given 6 weeks, wasting time is not a great thing. So in this way, write a common core or utility code base which you just import each year, changing it if you need to. In Java, this is very simple to do using a jar file. In C++, you could just have a package which you copy them to, or you can get fancy with shared or static libraries. That's up to you. But the point is, in this way, you're creating a sort of framework. You can either write your own framework, use an existing one, or put a framework on top of an existing framework, which is where things start to get interesting. So some stuff which has been making the rounds. I'm sure if any of you exist on Chief Delphi or the FRC subreddit, you would have seen a couple of projects. One's called the CCRE, one of them is called Toast, which is my one, and one of them is called Strongback. And what all these are is they're frameworks which other teams or other people or even the developers themselves, especially in my case, will use these frameworks to develop their code. So each one of them has their own kind of strong point. CCRE is designed to work across year to year. It abstracts WPRlib so that you can make your calls, and no matter if it's running on CRIA or RoboRIA, it will still work. Toast is very much based around simulation and module loading, so that you can kind of use the same module from year to year, the same file, instead of just copying your source files over. And Strongback, it also has some simulation capabilities and just general ease of use functions which make common things like data logging and control systems a lot easier. So how did each of these projects start out? Well, I can't speak for the other two, but I can speak for mine. It started out as, and here's the buzzword again, a research project. So a research project, as we call it, is just a project which we don't know if it's going to work out or not. So we keep it under wraps for a little while, and then when it's up to the stage where it's working, we release it to the public. In our case, this is actually a very special research project because it actually isn't branded underneath my team. It's branded under an organization instead. I'm not going to go too deep into that because we've got a limited time and I'll talk about myself too much, but that's fine. But basically it started out as kind of our common core, and then we kind of abstracted it to work with other things. You can do this exact same thing as well. So each year in your robot code, you can abstract little things to make up for little differences year to year. So for example, if we take the transition from 2015 to 2016, we gained 2 new motor controllers, right?
Mm-hmm.
The thing is, oh, 3?
Yeah, wait,
Hold on.
so 2015 to 2016, SD40,
We had the
Spark,
SD540.
Spark.
I think it was just 2.
Wasn't there? No, yeah, it was just 2. Alright, never
Okay.
mind.
Well, we gained 2 extra motor controllers, which mean that if you use those extra 2 motor controllers, I believe one of them only got like 1 use, so that sucks for that one.
Oh yeah.
I think that was a like 3D printed one. I can't remember. But anyway, that broke a lot of existing libraries if you wanted to use those, which also meant that if they built in that support, if you roll back to something like a CRIO, which doesn't, well, actually that's a lie, the CRIO will support it because it's PWM, but let's say it's like a CAN device or whatever, suddenly it won't roll back. What you can do is you can abstract that to make up for those little changes each year to year. So probably motor controllers wasn't the best example to use, but in terms of framework, the whole point is you want something which will just work. You know, you want a common core which you can just kind of import and then forget about. You can focus on writing your code for this year. The off season is the best time to do this. There's, I'd say that there's
some of the common core stuff that we use on 225 is Cheesy Drive. We use that from year to year. It's 254's the Cheesy Poof's tank drive class, which I recommend. I was going to mention it earlier, but then we played the video and stuff. That's definitely one. You just have to tune the constants a little bit to match up with the drivetrain you're using, but most of that can just be transplanted from year to year as a common core kind of thing. And then we also have motion control and PID classes that we've rolled ourselves. That we just like to keep from year to year. Then we do it, as kind of the way you're talking about.
Yeah, we have a similar thing over on over here at Curtin. We most of it is Toast's inbuilt, but you can have your own modules which bring extra kind of things, like an autonomous one, for example, or one which is quite recent called Blackbox, which keeps kind of all the data about your robot's life cycle over a match inside of a CSV file. But for the most part, it's logging, and probably the most important part, configuration files. Because when you put code on a robot and say something's broken, you want to be able to change it fast. You don't want to have to redeploy code. You don't want to have to rebuild it. So actually all of our motor ports, all of our motor types even, all our hard-coded, well, not hard-coded because it's in a configuration file, but delays, all kind of subsystem stuff is all kept inside of a configuration file, including PID constants. And I believe our configuration.
Yeah, that's the way to do that. You don't.
Or smart dashboard, but whatever.
All right.
Yeah,
so,
I mean you don't want to have to redeploy tuning PID, so yeah.
All right, so we're just gonna brush up on all of our questions before we run out of time. So the first question we got, let me just get it real quick, actually. Oh yes, so from Mitchell Stokes from Team 5817. He asked, what do co-hosts think are programming projects with the biggest direct impact to the success of the team?
I mean, from my perspective, it's kind of not even on the robot. I would say a robust scouting system. I mean, you can do a lot with your robot, but ultimately you can have a decent robot without a lot of programming. I mean, autonomous, it's from year to year, it changes a little bit, how much return it gives you. But spending some time even on making, a simple, like a scouting app or something that really meets your team's needs, because there's a lot of them out there, and sometimes you can find one that works. But I mean, a lot of times you can find somebody who knows how to make an app in one way or another, whether it's, hopping in Android Studio and coding it in Java, or, using some, pre-built framework for doing them in, drag and drop fashion, or anything like that. Just, making a good scouting system, because really, I think that's the key to unlocking the top tier for a lot of teams, is just, being able to go through an event, knowing what you're doing, even before picking for elims, knowing what your partners are going to do, whether what they're telling you they're going to do is what they're actually going to do, that kind of thing. Like we have an app that we can access from the cloud on all of our devices, and it helps so much during events. There's a lot of things that do help a lot on the robot side, but that would be my vote for the biggest contribution to success of the team.
I'd go one level higher and just say off-season projects in general. There's only so much you can do within 6 weeks, and yeah, sure, I guess you could write it after your robot's bagged, then go to competition and pray to God that it works. But I think off-season projects are the most important, and obviously scouting apps fall under that. Code which you use during the year, which consult your rule manual. If you write code before the season, it has to be open source if you want to use it within that season. That's actually a rule, believe it or not.
Yeah. Yep. Yeah, and I mean that's one of the biggest things about the directory of team code bases from year to year is that if you upload your code to that, then you can use everything you wrote that year, and like the reusable modules, that kind of thing.
Yeah, but I'd just say everything that falls under that umbrella will help your team a lot, because off season is the best time to practice.
All right, Alex, you have anything to add for that?
Yeah. Well, actually, after hearing our talk about how kind of having a common core and libraries that you can refer back to in years to come, I would say those have a pretty big impact on how your team how quickly your team can program to begin with, because if you write this common core, these classes full of utilities, if you do them once, you can reuse them for multiple years, so you're doing work that will reduce the programming time, because you'll have all those functions already done, and also they won't have to write those functions out again, every year. And so I guess my main point is that writing it once will help your team for future generations, which is a really big impact.
All right, so the next 3 questions, kind of, they're for individual people, is from Programming Mentor, I guess. But so the first one's for Adam, is what programming practices help build a successful auto?
I mean, yeah, we touched on it a little bit earlier. I'd say, being prepared, especially even just having that don't do anything auto, that helps in a lot of situations. And then actually, the practices that will get you to a consistent, repeatable auto that scores points. Adjusting to the game, like, this year it was good to have a modular auto that you could, pick, or even if you just wanted to pick like one defense, if you can. I know there's the whole big debate about bagging and practice robots, that kind of thing. If you can at all, just get some practice time in with your auto before like a practice match at your first event. If there's any way, on the practice field or something, just run it a couple times, make sure it works, and put the time in, even if other members of your team, like, especially if you have a different team culture that doesn't emphasize you're autonomous as much, like, it's just kind of like, all right, there's more important stuff, just really push for getting some time with the robot to make sure it just works beforehand. I mean, I know that's kind of dumb advice, but some people don't do that, so yeah.
All right, the next one is for, I guess, Alec and Jassy, and that's, for the others, what factors are you planning to improve in the future to build a successful auto? I guess Alec should probably answer this, because Jassy has the next question. So, Alec, what are you doing in the future to improve your auto?
Well, you know what, Jason, you want to go first? Or Jassy, I'm sorry.
I'll give like a quick one sentence. Actually build a practice field next year, because we didn't have one this year. Yes. And it's kind of important, it turns out.
Yeah, that's a good point.
Plywood is hard to find in Australia.
Yeah, our team also needs to do that. We only had, I want to say a half field, but it wasn't even that, because we had a tower and we had room for 2 obstacles and a low bar, and that really had an impact on how much we could test our programming. But what I was going to say generally is that so during this episode we talked a lot about having a better auton, how it could be robust and smart, and in order to do that. But our team this year, we didn't have any of that, and there's a couple of reasons why. This past year was our first year using Java for our robot. We switched over from LabVIEW, which all of our old programmers knew, to Java, which none of us knew at the start of the year. So it was pretty much our first time becoming literate with FRC Java. And then I'm sorry, give me a second. Thank you, I appreciate that. Gotta collect my thoughts. Yeah, I think it's basically that we didn't have, because 255 or 225, they use they use motion control and PID. They can they implement their web dashboards and everything like that. And they have variable autons, like they have a chooser for they can do nothing, or they can go over the rough terrain, or they can go over Cheval de Frise. They have all that stuff that we really didn't have. And at the we just actually finished going to an off-season competition here yesterday, and at the end of the day, our auton was literally drive forward at 70% motor speed for 4 seconds, and then do a quarter turn for about 0.7 of a second. It was just time values is what it was, and that's because we didn't have the expertise on our team to I want to say afford anything else. Mm-hmm. And Yeah, I guess another point that you guys talked about more was that it's really good like to have time, like practice time to test code and everything. That's another thing we did not get a lot of on our team that would have really, really, really helped us, develop our code and make it more mature and just generally better.
All right. So one of the there's quite a few questions, but we'll just get through them and try to be as quick as possible since we are over time. But basically, the last question from Progmentor for Jassy is: do you think that developing Toast, OpenRio, and Gradle Rio, etc., detracted from the success of your team?
I'd say it did kind of the opposite. So all three of those projects, and I guess Toast and Gradle Rio fall under OpenRio, started out as research projects of the team. They were kind of things which I did in my first kind of month of FRC. I started FRC last year. And then they kind of matured into this thing which I was ready to give to the community. And in fact, Toast itself actually won us the Regional Engineering Inspiration Award at the Australian Regional this year, which is actually what sent us to champs, because we were on the second place alliance, we were on the finalist alliance. So I'd say it's kind of, after going to champs, it kind of gave the students more incentive to like actually want to get to champs, don't stop at, okay, this is what we need to compete at a regional. This is what we need to compete at champs, and not come dead last. So I think it's going to improve. We came like 9 places off dead last, so I'm going to say that's all right.
Yeah. It's
not bad.
Sat there dead last. But yeah, so I guess completely did the opposite of detracting.
Oh yeah, it's definitely going to champs through that has helped the team a lot, and I think it's going to inspire them for years to come, and hopefully we'll be a little bit more competitive next year.
Great. All right, so next question, nice and simple. What languages do you guys use for your robot code?
Java.
Also Java.
Java, Kotlin, C++, there's a whole list of them.
All of them. All right, great. The next question is, what kinds of sensors do you guys use in your robots?
Yeah, well, we obviously use gyroscope. We used the Spartan board this year, which I have to say A+ to Spartan Robotics for that, because it worked like a charm. The built-in gyro that you can get over SPI was awesome, and it barely drifted. That was a great sensor. We use Gray Hill encoders on our drive base. I got into a rather heated argument with a certain couple programmers on Delphi that were telling me you couldn't get consistent encoder readings over the defenses this year, and that's why it was acceptable to slam into the driver station. To the contrary, I got pretty decent encoder readings, so I don't know what they were using. I was using Gray Hill encoders in Vex Pro transmissions to pneumatic wheels. So, yeah, that's, I mean, and then obviously if you consider the camera sensor, that was basically all the sensors this year.
All right. Alex, did you guys have any sensors on your robot?
Yeah, we did. Our drivetrain, we used cross-the-road magnetic encoders for our drivetrain, and then
the
our
ones that integrate with the Talons.
Yeah.
Yeah, those ones.
Yeah, we used those on our shooter. They worked awesome. I love those.
Mm-hmm. Yeah, they worked great until our last competition that we just went to, when we actually we lost a magnet on one of the shafts, so that basically incapacitated our auton, because at that point we were using encoder values, so I had to switch just to time.
Was it put in right? Just curious, because we plan on using them. Like, did you actually use a lathe and
yeah,
our the hole and stuff?
Yeah, our mechanical team did a good job of that, because they lasted through literally the whole season until this last competition. So I think it was just the stress of the use over and over that did it.
All right.
Oh, we used the ones that integrate right into the the planetary gearboxes, and I mean those worked great. We had them running at like 6,000 RPM for the entire season on the shooter, and yeah, they held up.
All right.
Mm-hmm. Yeah, and just one more thing for our manipulator on our robot. We used the encoders that kind of coincided, like Adam said, we had PG71 gearboxes, planetary gearboxes on our manipulator, and we used those built-in ones, and those worked pretty much flawlessly for the entire season. Not a complaint there.
All right. Just one last question. Talking about like with the PID stuff, it's when would you want to use feed forward?
Okay, so feed forward versus feedback. This is a very interesting subject, and it kind of starts to delve on the difference between motion profiling versus just a regular PID loop. So, what I find is best for feed forward is things like a drive system, oddly enough. I prefer not to use PID, but instead like to use a feed forward in conjunction with a feedback for drive system, because it removes a lot of the oscillation, but it also requires that the readings you get are accurate. Because if you're not, your oscillations are just going to get worse, and it's not going to be as accurate.
Yeah, I mean, there's a couple of different ways you can do it, like that have varying degrees of feedback and feed forward. You could just have like a PID loop with a feed forward constant, or you could have like a feed forward system with some feedback on the terms. But yeah.
He said by feed forward he means the feed forward value in the PID loop.
Yeah.
Oh, the
so
F10.
that's
okay.
Yeah, that can be useful. That's integrated really nicely in the built-in Talon PID loops. We use that on our shooter wheels to have like a really quick ramp up this year. I wouldn't use it, like we were tuning some of our new vision stuff for IRI just today, and like really some where you have like really varying use cases where sometimes you're gonna have to do a big sweeping turn and sometimes you have to do just a tiny adjustment. I wouldn't use a feed forward, because then you'll end up just jumping out of your seat right away if you want to do a tiny one. And it's not the best for the really flexible ones, but for like a shooter where you're just always ramping up to 6,000 RPM, yeah, go and use a feed forward.
All right. Think this was all said. We have all of our questions answered. Think it was a great episode. We will have an after show, but we will have a 1-minute break between that time. So see you guys in like a minute or so.
Awesome.
All right.
There we go.
I'm really surprised that my dogs didn't start barking in between that stream, because whenever I'm talking to my computer, both of them will come up beside me and start barking, but they're actually just both passed out on my bed.
Yeah, my dogs...
That's you playing StarCraft, and then they just, are yelling in your microphone.
What do they call it? My dogs bark routinely through episodes sometimes, so I'm sure everyone who watches here regularly hears them a couple times every week.
Hold on. If I have you on
And I have no
Snapchat,
dogs,
be prepared.
I have you on Snapchat, so I'm prepared. What's going
Screenshot
on?
it and put it up on the
Delphi,
stream.
Is that 3481? That's Bronx. What team is that? Bronx?
Wait, what's the number?
3481? Yeah, Bronx.
Yeah, that's Brownbots. We actually have a couple team members that used to be on their team.
Nice, tall robot. Yeah, when you said the thing about 2-ball auto, I just can't see a 2-ball auto ever working with your robot design. It's just...
Ours?
Yeah.
Yeah, no, we're awful at designing intakes. No holds barred. I'm gonna say that. 2015, we had forks on the front of our robot, and of course, the driver has to pick up the slack then, because you have to practice the crap out of your intake just to be able to do anything. So, yeah, I mean, we've made it work this year with the just intaking with the shooter, but it's taken so much practice, and there's no way we could do it in Auton.
You guys are just against intakes.
Yeah, I don't know what it is. We try. Last year after the season, we were like, all right, guys, let's just always promise to have an active intake, whether it's rollers or wheels or whatever. So this year we're like, yeah, we have wheels, but we completely did not do it well enough, because it's just
It's
our
the
shooter.
size,
Yeah.
Like,
Before Worlds, we were actually messing around with adding a roller bar, and seeing if we could do it in weight. We were really close, but the geometry of it meant that we wouldn't have been able to do the low bar, and we were just an inch over. And I was pouring my heart and soul into this prototype because I wanted it to work so much, but we couldn't pull it out.
Yep.
Mm.
It's always an inch.
With our robot, if anyone's seen a picture of it, I'll send you a link. There's a photo of it on the GitHub repo. It's basically a giant chute with 3 sets of flywheels, all directly driven by a minisim. So, basically, once upon a time, in fact, in Champs, we spun it up all the way, and we got told off by the field next to us for being too loud. What ended up happening was we turned it on, and we had a boulder resting in front of it by, I don't know, about three quarters of a ruler's length. Wow, that's a really odd way to say 22.5 centimeters, wasn't it?
Or 9 inches,
Yeah.
Yeah.
In the right way to measure stuff, right?
Yeah.
Go home with your freedom units.
We're home. We're all home.
At least it's daytime here.
It's
Yeah.
not bad.
But
The times don't
essentially,
they're not terrible. It's not like it's 3 o'clock in the morning when we go live for you guys.
Yeah,
Yeah,
that
that's
would be
true.
rough.
but basically, what would happen is that we would sit in there and we'd turn it on, and then we'd start talking about how it's jiggling a bit because it doesn't have it wasn't mounted on the robot. It didn't have all the structural integrity yet. And then suddenly we hear this, and the ball goes in and out. It generates a vacuum to pick up the ball. So we found, wait, we don't need to extend the intake in front of a robot. We just run the wheels fast enough and it will suck it through that hole in the bumpers. And it actually works surprisingly well.
Nice. Yeah. You had a lawnmower sounding shit,
Yeah,
I guess.
Oh yeah, there's a video of it on Chief somewhere. It does sound like a lawnmower.
Yep.
I can hear it
Bench
from
grinder.
Bench
a couple
grinder.
hundred meters off.
Wait, did it have bench grinder power?
Oh, it was much far. It had more power than a bench grinder.
Oof.
Shots fired. Where's 5817?
They're in the chat somewhere. He's been asking questions. Yeah, but I'm actually been.
We almost
thinking about
rivaled
shooting.
2013 shooter. Almost.
5817, I think, tried to shoot over to Hopper a few times, and they were actually pretty close. If they shot straight, if they could have been in their they could have been in the neutral zone and shot into Hopper's neutral zone from Newton.
Jesus.
Wow.
There was one
You
point
see,
where they missed a shot. It went over and hit the screen of Hopper.
Are you serious?
Hopper's screen, which is
If
really bad for field reset because we actually have to.
Yeah, the balls.
Yeah, we have to put the balls back where it went. So you got people just sprinting to go get the balls from them. And luckily they never did shoot it into the crowd. But if they did shoot it into the crowd, we would have been completely screwed.
No running. No running.
Oh no, there was definitely running involved.
It's like that announcer guy who kept calling people out by the color of their shirts for running at champs.
Oh yeah,
Yeah.
I remember that.
You see, if I hadn't been at champs before, it's my second year doing FRC and my first year going to champs. If I hadn't been at champs before, I would have said, shooting from one field to another, not that bad. And then, when you get down onto the actual dome, it's like, oh, okay, this is actually kind of big.
Yeah, no. There's a big gap. This is not small. I mean, it's not as
Because we
big
don't
as the.
have stadiums like that here.
Yeah, it's not as big
Or
as
we do, but we never go to it.
the I guess that would be the I guess we can call it the length of the dome. It's not the long side. It's the shorter side it's the two Einstein fields, Newton and Hopper.
Yeah.
So, but that's still a sizable distance away.
It's pretty decent.
I was really disappointed though they didn't actually ever get it into the field during a match because that would have just been so funny. It would have hurt.
That would've been
It would have hurt
hilarious.
Hopper's cycle times. It wouldn't have touched ours. So yeah, it would have been pretty funny.
Is it a tech foul if it occurs on a different field?
I don't know. I don't think there's precedent for that.
What a good question.
Yeah.
If I shoot it from the Australian regional to the New York regional, and it goes in, does that count?
It gets into the jet stream. Yes, you automatically win the world championships if you manage that. It's just,
Yes.
It
How
floats
accurate does
across
that
the
vision
ocean.
code have to be?
Well,
You have motion profile to do that?
nah, dude, just go full power and hope for the best.
Did Adam break again? Yes, Adam broke again.
I think he did.
Oh.
He's just kind of staring at us.
Yeah. Now we have two stationary images. Oh, he's back. All right.
There we go.
He's
Oh.
awesome. Skype's being stupid as always. I've still been looking for alternatives to
Yeah.
Skype, but all the alternatives have change the sizes of the cameras change, which I can't do because I have to take
Right.
screenshots of it. So
Yeah.
Slack has
Dude.
a video chat feature, but it's still in beta, so I don't want to rely on it. Although I for all I know, Skype's probably still in beta too. At this point, based on the amount of bugs.
It's just one big open alpha, you know.
I feel like
Yeah.
it is.
Yeah.
It's basically every Microsoft product, you know.
Is this a new Blizzard IP?
Well, maybe it's because they got rid of their software testing divisions, which is, by the way, a real thing. Microsoft got rid of
Wait,
all
really?
their software testing divisions, yeah. So,
Oh, smart.
yep.
Yeah, why would you need that?
No,
It's called the
Yeah,
final
no.
product.
Yeah,
Yeah.
it's a feature, guys.
They're taking the FRC strat.
Do they know this company called First? Yeah, basically, it's like the FMS every year, but or the the scorekeeping software. It changes 50 times a year. They just never get it right the first time.
The FTC, the quality of the FTC FMS software is hilariously bad.
It's terrible.
Yeah.
No, the quality of
my
FTC in
God.
general is just hilariously bad. Like the robots are alright, but the software stuff and the apps, the apps are awful. The interface between the phones and stuff. And down in the team,
Yeah, I helped out our
use it.
FTC feeder team this year with programming, I was appalled at like the stuff they had to do to set up their robot control system. Like the stuff that first made everyone do was ridiculous.
Yeah.
Speaking of which, FLL, we hold FLL competitions at Curtin, and we had one last year. And instead of using like the official quotation marks scorekeeping system, we just had an Excel spreadsheet with a whole bunch of macros on it. So it was cells filled in with a color and like a single button which was like start, and it would keep track of the match time. And
oh yeah, we did that
it.
because we couldn't find any good like timers. So we did like an Excel macro with like a timer and like scorekeeping for an off-season FLL event we hosted.
Yeah,
That's funny.
FLL events are actually surprisingly fun. They're nice.
I've never
I
actually
like them.
attended a formal FLL event. The New York City Regional, at least in the past years, it's not going to be like this year. They had FTC, Junior FLL, and FLL, and FRC running all at the same time in the same place. So I got to like see FLL and Junior FLL there, but like I've never volunteered for an event or gone with a team or anything. I'm really not very familiar with the program. To be honest, like from what I've done a little research, I just prefer VEX EDR over it. Because it's competitive.
Yeah, I mean, I started and coached an FLL program, so I've had some experience from there. But yeah, I mean, VEX CDR is definitely better though.
Yeah, it's just like, I just don't like the idea of like not being competitive. Because I mean,
Yeah,
what you can have FLL kids that are like 8th graders, and I mean 8th graders don't want to do like this like demo kind of thing. They want a competition. That's how I feel at least.
yeah. I mean, it was a little different experience for me because my entire team was 4th and 5th graders. But then it feels kind of weird. Like, just go to FTC. It's like once you get to 6th, 7th, 8th grade.
Yeah.
It doesn't.
We actually don't have FTC over this side of Australia yet.
Really.
It's not a big problem.
So we've kind of got this
Do you have
little
VEX?
gap.
Do you have VEX?
We don't. Not yet.
No. Yeah.
I'm
Vex is
gonna
more
keep
expensive,
saying
right?
yet. I'm not gonna say anything else. I'm just gonna say yet.
You just have to get, another, crap, what's their number? Wise Thunder, what's 3132, right? That's their number?
Yeah.
Yeah, you gotta get another 3132 to start your
We
VEX
work we work very close with 3132. They're very nice people. They're babes. I love them.
Wait, what you
All
call
the
them?
Australian teams are so nice. There is very little beef.
And then they met the French-Canadian teams, and they no longer thought everybody was nice. I'm sorry, French-Canadian teams, if you understand anything I'm saying right now. Okay? It's not directed at all of you.
Yeah, I thought
can
FRC
take-
was this really nice program,
The
and then I
insult, the
met this
insult
guy
was
called...
lost in translation.
Don't worry,
You
guys.
know,
We
it's-
can,
don't worry.
we
Yeah.
can take shots at them. They don't know English. Man, those
Jesus.
Chinese FRC teams, guys. Actually, we had a Chinese team at New York City, but we never got to play with them.
This is getting touchy now.
Yeah.
Well, I'm actually working pretty closely with the Polish team, because I'm.
There is a Polish
my
team?
parents are from. Yeah, there was one this year. They went to. Oh, it was like Windsor. No, there was the one that like the. I'm just gonna look it up. They're called Spice Gears 5883. And we actually had a Polish exchange student on our team this year too. So we're working to kind of figure out some stuff. They actually had a really good robot
Yeah,
ready.
Windsor,
They,
Essex.
they built a practice robot. Yeah, Windsor, Essex. And so they actually had like a auto align high goal shooter ready, and they were like they actually showed me some video of practice where they were like just firing off high goals, but the manual was translated a little weird. Well, like they don't actually have an official manual translation, so they had to do it themselves and stuff, and so they missed a bunch of rules on like motor controllers. So they basically spent the entire event just rewiring the robot, and it's like everything broke.
Ooh.
And like I felt really
That's
bad
rough.
for them. So yeah, I'm working with like first headquarters and stuff now to figure out like what we can do about translating
Translating.
manuals.
Yeah,
We had
Yeah,
something
like-
similar
I mean,
last year.
like stuff like the bumper rules are confusing in English. Like I can't imagine like the
Yeah.
translated
Yeah, really.
versions.
Speaking of which, I have two stories.
Yeah.
One of them was from last year. A team from, I believe it was China, they also had translation issues with the manual. and they ended up using a car winch motor for their lifting mech.
Wow.
So we sent a couple of members over, and we spent like the entirety of the practice day essentially rebuilding the robot because the
It's
motor
an
is
automotive
absolutely
motor, right?
huge.
Right?
It's a window motor.
The second story was a team came to this year's Australian regional just without bumpers. There's no bumpers.
We
So
don't need those.
we spent the entirety of the first.
Wow.
We spent the entirety
Wait,
of the first
this
2
year?
days helping them build bumpers. Yes, this year.
Yeah, were they like a rookie last year or something? So they never experienced bumpers.
No, I think they were rookies from this year because I don't think I saw them last year. But
Oh,
I might
huh.
be wrong.
That's interesting.
We had a
all
lot more
Australian
teams in
are
Australia
basically
this year.
rookies last year, right? Because a lot
Yeah.
of the teams only participated in their first official competition last year.
Depends. You can get a team registered without them actually attending an official event. Like, a good example of that is my team and 4788. 2 of us are at Curtin. 5663 wasn't up until last year, but we did DDU, the Dual Down Under, in place of the official FRC Australian Regional, and we still have official team numbers for that. So that's great.
Yeah, I know that was a thing because I was like,
Yeah.
I was really confused at how 4613 was a team from the 4000s, but rookie year was
yeah.
technically in 2015. Yeah.
Alistair, phone home.
They're the second year team and they're significantly better than our team. Alright guys. Just gonna go home now. Their team
GG, guys.
IFI.
Nice.
God. Yeah.
4613 are very nice. All the Australian teams are so nice. I feel like it's so kind, but I want the day to come where we get more teams in Australia, but I don't want the day to come where we get so many teams in Australia there starts becoming beef in between teams from like different states.
Oh, there's some teams have some like crazy beef with each other. Like,
Yeah,
I'm not gonna name names,
not gonna
but
lie.
there was like a team at Worlds that I was sitting with for Arnstein, and they were rooting so hard against a team that was on the winning alliance. Again, not gonna name it. Like, and there was reason for it. Like, they just like those teams just hated each other, and they like a girl started crying when they won. So.
Are you serious?
That's serious.
Jeez.
Ouch.
Wow.
So yeah,
Huh.
apparently they're like, we'll never like hear the end of it. So yeah, there's some beef.
I remember at Champs, like, the Carver field was called the Cursed Field because for the entirety of the first day, I don't think there was a single match where there wasn't, like, a field or communication fault. Like,
Oh.
half of it wasn't even, like, the robots. Like, I know one team, I'm not gonna say their name for whatever reason, but, their radio just didn't work, and they swapped out the radio with another radio, and it didn't work. And another radio, which was known to work with other team numbers, didn't work with their team number. And they tested that radio on another bot with different electronics, and it didn't work with that team number. So,
Wow.
I don't know what was going on with Carver Field. We probably got, like, the field which was the last one in the truck and probably fell off on the way to the event, and then they hastily loaded it back in.
When you said the whole thing, like
Yeah.
the curse field, for a second I tried to figure out if you just said Curie really weird.
Yeah, yeah, exactly.
I was like,
Wait.
Carver and Curie?
Okay.
Like, did the accent
Yeah,
didn't
so are you
happen?
familiar with the Curie curse?
I've heard about it. All I know is that the
Yeah.
Carver curse this year was real, and then we ended up winning. So, you know that song which they played, and it said Carver's got a winning team? Foreshadowing.
Yeah. But yeah, no, I find it hilarious the Curie curse is still holding to this day. I mean, okay, no offense to the Poops, but like not making it to Einstein for 2 years after winning on Curie.
They
don't
said
know,
they
something's
said
going
the
on here.
curse went poof, but I mean, I think 254 is
Yeah,
curse now. So
Yeah,
The
I don't
curse
think they
didn't go
poofed any
poof.
curse.
okay, they carried the curse with them.
Yeah, because we were on Carson last year with them, and watching those matches, oh my god. I mean, Curry curse is real. They just, when everything fell over, and then like this year with the double yellow, red card stuff,
That's
like
crazy. I still disagree with that.
I saw that.
I would.
Yeah.
I was fielder sitting in the field, and of course, every single time there was a big match decision, I like ran over there because like they didn't really say anything. So I was just like acting like I was playing with the balls, so I could hear everything the red ref was saying and stuff. And like I wanted to just sit there and be like, no, like that's so wrong, and like, but I didn't do it because that wouldn't have been a good idea. Yeah, just as somebody who like was there the entire time of that and like sat by the poofs when they like connected to the other robot stuff, like it was kind of BS. But whatever. Because what was crazy about that match was I went, oh, the other team's gonna get a red card. I was expecting red cards on the match, but on a different alliance. And I was like, I was standing next to like I think it was like one of the other fielder starters, like Andrew Neighbors from 1671, and he's like, "Are you guys like members of the Pooh?" So like no, but like it messed up because we like got really angry when like the red cards came up. Well, the red card.
What were the red cards? Oh no, I remember. One of them was for
it was for
illegal tethering,
and the
other
one
was stepping over during order.
Which was both of them had exceptions because they didn't ask the FTA to tether, but they asked a ref to tether, which is technically not allowed. But the ref said yes, so like, I don't know. I think that's kind of BS. And then the other one, they stepped over the line, right? But it was because the wall got knocked, and the controller fell off, but it didn't hit the ground. So what they did was they picked the controller up and like moved the cables around so it'd be like back to set, and they said that wasn't allowed because it wasn't saving the control system. So,
yeah, all that stuff was.
Like it was just like why why do that?
Tough.
And like if you watch the
Yeah,
match,
I understand. Yeah.
I understand like the rules are rules, but like it's kind of just like I don't think like the other alliance did not want that.
I understand
red
the
card to
tethering
happen, I'm sure.
one and like keeping that as a precedent. I'm all about that. I mean, I've gladly taken tethering yellow cards in the past just because they need to be there, but like the saving the control system. I mean, it's been debated like the entire season, and then when they just like brought it to a head like that, that was a mess. So
I remember before we went to our first event because I know what to do as a driver, but we've also got two other teams, so it's like I have to try and make it clear to everyone. I said, look, the rules say you can dive, or well, not dive. That would be overly dramatic. You can save your control system from falling on the ground, but unless it's like for a fact it's going to fall down, just leave it, because I'd rather not risk the card.
I mean,
because like we're using classmates. Those things you can drop it from like the Empire State Building, and they'll probably bounce back.
Yeah. That's why we use ThinkPads, because like the toughness factor of them.
Oh yeah, ThinkPads all the way.
Yeah.
We used classmates this year, but we're getting a bunch of ThinkPads because we really don't like the classmates.
Yeah, they're just so slow.
Yeah.
And, like classmates
Neither
are just
do we.
like it's a good backup computer, I think, like for just a driver station. But if you're gonna do programming on it too, which like I think you probably should, at least like at the competition, just like you don't want to use a classmate.
Yeah.
I used my own laptop for programming, and it was our driver station for a little while, and then FMS was just like, "Oh hey, you're using an Apple computer, which is boot camped. I'm just not gonna let you on." So enjoy.
We have some like
I use my own computer for programming too.
New York City has like the New York City Department of Education has like deals with Apple, so every computer in those schools are Apple computers, like legally have to be. They can't actually have Windows computers, and so a lot of teams, if they're using those computers that they got like either bought through their school or like have from their school, they're Macs. So we have a lot of teams that like have to run like VMs and stuff to do that.
Fun fact: the initial reason that I wrote Greater Rio and from that stemming Toast was just because I had a Mac and I hated the Eclipse plugins.
Nice. That's hilarious.
That's like the entire
that's like
reasoning
Nick's programming
behind
things. He just like programs random stuff because he's like something like inconvenienced him once. Like he wanted to change music from his bed, so he's like, oh, I'll program like a whole program to like change music for my bed, because that's what you do.
Hold on, wait right there. I have a GitHub project.
Nick is
So
putting
I
like 3
was at a
bots
LAN.
for F4 because he like wanted to make something easier. Like there's a bot that tells us if like a connect response he made. Like I think he's working on a bot that like if you do @board, like it actually notifies all the board members. I don't know if he's like actually following through with that, but that was like a thing.
Okay.
Nick does
Check
cookies
the
and
Slack. Check the Slack channel. I was at a LAN
The no
Not
nonsense.
recently.
What does this do?
I was Hmm?
Oh, LAN parties to suggest YouTube videos for protected
Oh my
content.
god.
I was at a LAN party recently, and we have projectors because we have the LAN party in one of the conference rooms at the university.
Mhm.
Yeah.
And we didn't really have a clean way to suggest YouTube videos to play on the projector because we pull up like the weirdest stuff you can imagine, like memes from the deep dark corner of the web, and
Yeah.
so
Mhm.
we get people to suggest it, but we didn't have a nice way to do it. So I spent like 5 hours, two hours of which was writing the script, and the other 3 hours of which were playing Overwatch to write this script. And basically, it's a web server, and you log into it and you suggest a video, and it sends it to a VLC instance which is running.
Nice.
Because
Yeah.
VLC.
We
you can
wrote
have
something
a remote
similar for the
control.
shop after everyone started arguing about what music was going to be playing. So we wrote like a like we called that like a jukebox that people would like vote on the next coming song and stuff from like
That's
a
cool.
Spotify playlist. Yeah, it was a kind of cool project in the off season after we got into one too many bickers about the music that was playing because somebody was playing like country and somebody else wanted Disney and then I wanted like the glitch mob. Yeah.
Yeah, we have
So-
those arguments.
Ooh, the glitch
Just
mob.
go-
Luckily,
This is
probably
where you
next
play
year will
all
be
three at the same-
mostly EDM stuff, because okay, so we had like our like graduate, like our like more important like the graduating senior that was like with us like all the time, like every day, like the most dedicated
Mhm.
graduating senior, liked like the same music as our mentor, as our lead mentor.
Mhm.
So basically, we had to listen to their stuff like all the time, and
Mhm.
like no one really liked their music except for them. And our other mentor is an orchestra teacher, so once in a while we'll be listening to that sort of stuff. But yeah,
Nice.
next year we'll have like, because the senior's leaving, we'll have an overpowering for electronic music, so we'll probably listen to that most of the time. Hopefully we don't get like 100 freshmen that all like country music though.
Yeah.
All you need
Like
is
our
just a
team
24/7
culture has
loop of
changed
anime.
so much. Yeah, no, our team culture has changed so much since like the days in like 2013 and 2014 where it was 2 students like who were really committed running it, and one of them was just like a huge EDM fan, especially like Glitch Mob and Daft Punk, and so he would just play it on his laptop like constantly. And then we got like a bunch of other people, you know, from all different kinds of perspectives, and they were like playing Disney and like country, and everyone like all the old timers are like face palming, and yeah.
Yeah.
Right.
You gotta be careful with country.
Yeah.
Country could spark some heated debates. Luckily, we have no one that's into that. We had like people like punk people and stuff like that would play that sort of music, and yeah,
Nice.
music's
Mhm.
always a big
Yeah.
fight. I think we fight about music more than we do about robot design.
I just kind of sit in the project room programming with headphones on, listening to like YouTube playlist.
Yeah,
But
we're
the thing
gonna-
is, I don't put in a playlist. I put in likes. So sometimes it skips to a weird video, but I just let it play through.
yeah, we probably will have like a separate CAD and programming room next year. So I imagine that's gonna end up how it's gonna go. It's gonna be like all the people CADing and like the people programming are just sitting there with headphones on, like just like chilling there quiet. Like the CAD people and they're probably be
Nice.
talking to each other quietly,
Yep.
but like, yeah, that's gonna be nice when I want to act like, because I've the way that our room's set up now, it's like you'll CAD in the same room as like people like sitting there with a chop saw, you know, like an abrasive chop saw that no one can
Jeez.
talk over it. So yeah, it's just not a fun place to
Ah.
CAD. So I
Right.
just CAD at home.
We
We
We got
have
so
a
much more
computer lab
spaces
to
here. I'm
use
so
for that.
glad.
Yeah, we're meeting with our super. So okay, so we like there's like spaces connected to our room that it's like bullshit that we don't have them because they're used for like two of them are used for trash for computer stuff, and the other one's used for a storage room. So that's like a little more rational. But like the two ones that are just straight up used for trash, like okay, like it just needs to get thrown out and like or just put somewhere else that's not an above ground room. Like we have basements, so
Yeah.
yeah, we first pitched it to the board like nonchalantly, and then like nothing really came of it. So then we went back to our board meeting and like straight up like showed a map of the room and like we're like these are the rooms, like we need them. So now we're meeting with the superintendent like in sometime this summer,
Nice.
and we're gonna like walk him through and like
Yeah,
show him
we're
the
not
tracks and
actually-
stuff.
Yeah, we're not actually at a school. We're from like 12 different school districts, so we're just, like in this industrial campus, and we're in like this extra space that this like the owner of the building has, and so we were always in this one room, and then we got like this like a one company moved out, so now we got like an extra 1,000 square feet. So we have like 3,000 square feet total now, and it's awesome.
Nice.
That's really nice.
What's that in a sane unit of measurement?
Now you're gonna have to do that yourself.
Two large rooms. With basically it's a field and a half.
Nice. We'll
Nice.
for next year it should be we'll have a half field, a machine shop, storage room, and a computer lab. So that'll be fun. Like the machine shop will be like sort of small, but like we'll be able to fit everything in it. It's just gonna be a very. It's also a garage. It's like it's about the size of a garage. So like, but when you just dedicated it to machines, like no storage in there, nothing, just machines, it actually kind of works out. And then
You see,
yeah.
the programming room, for me, is a special place called my bedroom.
Yes. Honestly, okay, so like my setup at home is like triple monitors, a very powerful computer, so like CADing on it is just a lot easier. But
Right.
I have triple monitors, but I'm
both
not
our
so great at
CAD
computer.
computers at Robotics actually now do have triple monitor setups. So
Ooh.
Nice.
That's nice.
basically we just
I only have
we
two
actually-
monitors.
those aforementioned trash rooms, well they have a bunch of monitors in them, so whenever we need an extra monitor we just go in the room and take one. So
Nice. We have a mentor who's lead of IT for the biggest law firm in the world, and he gets us so much free crap. So he got us three 60-inch like IP TVs. Two of them are mounted in our like computer lab
that's
area,
cool.
and one is just used for the main CAD computer. Like you sit there at a desk with a 60-inch monitor
Wow.
in front of
That's
you.
sweet.
Like, it's
Yeah,
hilarious.
that's really cool.
We call it Big Bertha, and there's the desktop is a donut somebody catted has Big Bertha written on it in icing. So yeah.
Yeah, well, one of the CAD computers is actually like a computer
Do you
I
know what we
donated.
call that? Do you,
What?
we
Wait, what?
we call those big monitors macular degeneration.
Nice.
That's their official name.
Oh yeah, there was a team at like in our area, 3419, who had a 46-inch TV as their driver station computer.
Are you
Why?
serious?
Yeah.
Why?
And then a giant
Did-
camera
no.
pull. They were the team who figured out the camera pull thing. So they
Really?
took it a little too far because they figured out the camera pull thing, like week 2 of build season. They were like the Q&A response about it and stuff. So they
Right.
like built an entire like driver station out of like extrusion and like had a 46-inch
Jeez.
TV on it and like a giant like camera pole with a Nikon DSLR at the top. It was really intense. And then-
Wow.
And
Why?
they used it at New York City.
That's dangerous.
And then yeah, I thought so too. I posted it on the thread. They end up, because like I bitched about it, they put like a stool underneath it so the driver station thing didn't tip over and collapse, and they didn't break the field. Which
I'm pretty sure that's
Oh.
illegal.
yes, it's definitely because they didn't have a weight limit on those because it was like brand new. I mean, they deployed it at a week 2 event, but then
Yeah.
their next event, which was Tech Valley, the inspectors ruled it unsafe, so they didn't get to use it. And then they just didn't
Yeah.
use it at Champs. Oh, by the way,
Dude, by chance,
if anybody like
46
didn't see
inch.
it, like 3419 played the best defense at Champs. Period. Like no one got to see it
Really?
because they lost in semis, but like everybody like just looks at like 11-14's run this year and just goes, oh, they was just because it was a bad robot. No. It was because they completely got shut down by 3419's defense. Like, do it. Yeah.
Those giant screens at like events. I think I saw one of them in person. It reminds me of like those things that you hear like old folks say. They're like, You kids, you'd rather be looking at a screen which, like, shows reality than actually experiencing reality. That's what it reminds me of, because you got this giant screen blocking the view of the actual field, which you're looking at on the screen.
Yeah.
Makes me so mad.
No, it blocked the entire. Basically, like, if they wanted to like check the robot, they had to like peek through the little corner left in the driver's station. It was pretty bad, but
Yeah, I could never get used to it. We from our champs, we set up a camera pole with a GoPro on top, and then we had like a 30-inch monitor off to the side, and like I think I used it twice in competition. Like for all of the painful carrying around that our operator had to do with it, like I felt so bad. It never got used because it's like I have the robot right there. For like the two niche cases where there's a ball hidden behind some defenses, yeah, I'll look down, but otherwise it's just ridiculous.
Yeah, we considered doing a camera pull too, but then we were like, we're just not going to use it. Like, there's no reason to do it. It's just a hassle.
We didn't even consider it. We were just like, you know what? If you want to see a robot from up tall, just get on your toes. That's it. Just do that.
don't ask what I'm doing. I'm trying to get one of their matches to show.
Oh, I'm watching one right now. I'm watching the one where they beat them 200 to something.
Was that quarterfinal 8? Or
Quarterfinal 4.
was that the one that got tipped over? Or no, they got tipped over in against 330, I think actually. That was pretty bad.
Oh, they got tipped over against 330.
Yeah.
That's hilariously ironic.
No, like they were not that far from, like if they had another mistake like that, they would have eliminated the winning alliance.
Really?
Yeah. But yeah, like you could see their defense. Like it's really nuts. Like I haven't seen defense that good. I guess that's because pneumatic swerve. Like you better be good at defense at that point. But still.
Yeah.
Drivers behind the line.
Yeah, this is kind of funny to watch. I've been wearing
Drivers behind the line.
Team Rush t-shirt.
3,
I got
2,
a champs
1,
all day
charge!
today. I changed into a Technopart polo. But,
Robots moving
Alright.
towards the
I
outer
actually
works.
got the video.
I wanted
Three
them
across
to
for
do well
red,
so
3
bad.
across for blue, lining up now for the high goal shots. 2 in. 2 in for red. 1 in for blue. This will set us up for a 10-point advantage to red as we move into teleoperated. Bert back on the field. Having gone in for maintenance during the quarterfinals, come back out strong, gone in for maintenance during the semifinals.
Oh, I put on the wrong match. Wow.
Whoops.
I just realized that.
I was gonna say.
Wow.
I don't
It's
see
like-
34-19.
That's impressive.
It's like
I call.
it's 10 o'clock right now. I have to go.
Oh yeah, actually, you
Okay.
know what? We'll watch this match and then we'll leave because it doesn't matter if anybody leaves at this point. We're not.
Yeah, I gotta get going too also actually, so.
It's like
Yeah.
10 a.m. I have things to do today and I didn't sleep at all.
God,
God
please.
It's
help
10
me.
p.m. here.
Yeah, it's 10 p.m. for us.
Oh,
Yeah.
lucky. You get to go to bed.
Haha, that's funny.
I think I'm hosting the call, so one of you might
Behind
have
the
to
line.
like pick it back up.
3,
Okay.
2, 1, charge!
Yeah, well, I'm leaving, so we might as well just also.
Red Alliance
All right,
looking to
yeah.
stay alive.
Yeah.
Bye guys.
Blue
Thanks everyone
Alliance
for
looking
watching.
for the
Yeah.
upset.
I'm just gonna finish this match
did.
because I started it.
All
so.
robots across.
Everybody, see you guys.
High goals score by red, 2 by red. Blue Alliance waiting their turn, and they will now move into teleoperated, beginning to take
So yeah.
shots on the castle. 120 scoring. Cleveland
Yeah,
team
basically we finished the
on the
stream.
high goal. Blue
Everyone
Alliance
just left, but
beginning to
I talked
weaken.
about a
The
match,
Red
so I'm just
Alliance
playing
castle
it.
scores on the high goal, successful. 330 once again. Beach Boys scoring. Cleveland's team scoring in
And
the
the reason
high
why I was
goal,
talking about
and
it in
there goes
particular
Sir
is 'cause
Swerve-a-lot.
I thought 34-19's defense was probably
Jumping
some of the best
in.
defense at all champs. This wasn't as
Hawks
good as in their
defending, putting off
their
the
quarterfinal
aim
matches
of
against
330.
11-14.
So accurate
11-14 they
during
completely shut
competition,
down.
under harassment.
But yeah.
They're able to keep the aim off. Doing the same to 120. Continual bumping, not enough to keep that shot from 330 going in. 24-81. Roboteers are scoring in the high goal as well. Infinite Loop moving into the Red Alliance courtyard looking to score. Shot goes wide. And there goes the Blue Alliance flag down on the Blue Castle. Red Alliance, their castle getting weaker. 2 more boulders required to make it susceptible to capture. Infinite loop going wide. 2481 going wide. 120 scoring in the high goal. 330 beach spots lining up, but Swerve-A-Lot keeping them out of alignment with that wrist on top of their shooter. 330 able to score despite the beat they're taking from Swerve-A-Lot. 2481 puts it in, 30 seconds remaining. All robots now looking to converge on their opponent's courtyards, looking to capture and potentially scale castles. There goes the last one for Blue Alliance, putting in a couple of security boulders. 13:05, heading out quickly to maybe collect another. 120 going up. Capture for blue, unless 13:05 rolls off. Capture for red with a scale. Keep your...
So yeah, I'll just switch back. They got a lot of penalties, but they did play some pretty good defense, so good job to them. And yeah, if someone saw a better defense at Champs, email it to me. I didn't see any. So yeah, guys, it's just me now, but if there's still 9 people watching, so if you're one of those 9 people, I'm glad that you liked today's episode and stayed all the way till here. Catch you guys next week. I don't remember what the topic is. It'll be on Chief. If you need it, like, if you want to know it, just email me and I'll tell you. So, yep, see ya.